This is a map of the UK, and around the UK there are dozens of power stations. So let us suppose we have a power station here, here, here. So this is purely arbitrary the way I've drawn this, but each of the red dots represents a power station. Each power station will generate a 25 kV, and then they put the voltage up using a transformer to 400 kV or 275 kV. So if we go with 400 kV, what happens is the generating companies take the power they generate and they connect all of the power stations together in what we would call a ring. So this is right around the whole country, and this is 400 kV. So that's 400 kV. The next step is to bring the electricity closer into towns, because this is out of towns. So let's have a look at that next. And we need to consider how we're going to draw that, because this is an extremely messy little drawing for me to persist with. So I'm going to say, oh, missed one out. So there you go, forget that. I'm going to move away from the map of the UK and just have in your mind that we have a narrow, long, tall, thin country. And I'll use that diagram to begin to explain the next step. So here is that diagram. I said we'd represent the UK in a simple fashion. Let's suppose we've got a long, thin country, which is what I've tried to do here. And each of these black circles represents a power station around the country. And these are all linked together like so. And these would be at 400 kV. So that's our ring, which travels around the country. 400 kV is a problem as we get into towns, so we need things to be at a lower voltage as we get closer to a town. So let's have a town. Let's get rid of that. Let's have a town. So here is a town anywhere in the UK. And what happens with the national grid is they will take a power supply which will be typically 132 kilovolts and bring that closer into a town. And this could be fed from multiple points on the grid system. It doesn't have to be the single nearest point, but each of these will be 132 kV. So to get from the outer 400 kV, we use a transformer at each of these points, and the transformer steps it down to 132. Before we get into the town, let's just have a look at what may happen along here. There may be heavy industry, and at some point we may take another transformer and we may supply heavy industry. This could be something like a steel plant, a coal mine, a car plant, perhaps railways, very large enterprises which consume huge amounts of power. And these will usually be fed at either 33 kV or 66 kV. So quite unusual and very high, very dangerous voltages still. This would normally be on the outskirts of a town. So let's come into the town itself, and in the town we don't want huge overhead voltages with huge pylons travelling through towns carrying 132 kV or worse still 400 kV. They're unsightly and potentially dangerous. So we get to the outskirts of the town and we drop the voltage down to 11 kV. So we drop it down to 11,000 volts, and at that point we run the cables underground and we run them to appropriate parts of the town. 11 kV is then transformed down very locally to you, wherever you are. It's transformed down to 400 volts and 230 volts. So 400 and 230 volts. This is what we use in domestic premises. This is what all of our standard equipment, like perhaps a computer, a projector, a kettle, a toaster, they rely on 230 volts, and we don't bring 400 volts into a domestic property. But 400 would supply something like a small industrial unit and light industry. In all of the handouts which follow, I'll take you through how we get to this point, and we'll analyse that a lot further. So this is just one town taken off our grid, and there would be other towns. So there's town 2, town 1, this is town 2, and we'll have a very similar scenario. This will be fed at 132 from various points on the grid, and we transform down to 11 kV. Take the 11 kV underground wherever possible on a steel or armoured cable, and then within the town we drop it locally at a local transformer down to 400 and 230. So let's look at the next step.